but a lot more easier than the structure we have today, with a lot of different interfaces and as well different technologies in use. Let's maybe give you a hint of it, what goes on if in that project. So at some point on the very top, the geometry has been generated or has been created, and the geometry would been put in that, or not would, is put in that database, and then the timber planning starts, and it's going to use that geometry from the database. It's going to enrich it with more and more information, drillings or joints or whatever it will be, and then puts the BTLX file back to that database. And the ERP stuff in the middle of it is gonna do its scheduling tasks, gonna calculate the production dates, or maybe as well enrich it with sales information, for instance, or just material information. And then the COM part is going to get the BTLX, is going to generate its machine code, its G code in the end, and the machine on the below here will accordingly set some feedback of statuses and production time in it, and it can be used on the right side through the whole process. Just to give you a hint how that looks like, we made some videos. It's not that quickly, it has its steps between, but the geometry is being created here in this example in Rhino. We just put a very simple example of it with 2 beams. It's going to be generated. I know there is a lot of different ways how you're going to create that geometry, and then it gets interesting. They're going to put it with that Python tasks into the database. In the next one, you see our JSON structure which we built up, where every information is being stored. Of course, we had a lot of discussions, different perspectives on it, so it took us a lot of time to get to that common sense of how that structure should look like, and I think that has to be elaborated by tomorrow even more with what are the rules of this JSON format. And Jonas took care of all the infrastructure. Thank you for that. Where is he actually? Okay. But he has done great work so far. And then what you can see here is it's not only putting your data in it, it's as well getting some data if there changes can apply, for instance. And then you have the possibility to get back all this information as well, which is today kind of very difficult, because you don't know where at which point the data actually is, and it's not accessible at this moment. Of course, that has let's say a lot of work to do regarding rules and how you handle this. When are you going to put that data back? But it's a first step of making it possible or acceptable. If we reach the phase of timber planning, and then you see here on CAD work, in here you're going to enrich it with different information, and in this example he's going to put through the API, he's going to put all the information directly into the database. So you have your not only you have your parts, you're gonna maybe enrich it with different parts, screws, fittings, or whatever is needed at this stage. You have your geo ID, you have your parent ID, so it gives you a clear structure of all the elements which in the end have to be produced. If we reach that layer of ERP, we're gonna purchase these parts, and by purchasing over a web shop or something like that, you're gonna write back the material status, ordered, for instance, delivered, or whatever it is, and gives you overview on the other stages. Yes. Or another example would be if something changes in the production. Maybe the construction site is delayed, so you have to put your production date later back on. So you're gonna do the milling work 1 week later, and that production date would be immediately uploaded to the database. So you know it has not been, or it's scheduled on another date, for instance. Or just to get an overview within the production, you have to imagine in bigger projects, different companies are working on the same project or the same overall project. And then you have an overview of what has been produced yet, or what is the status of the part in it. And this information is today it's quite hard to get this information so far. Okay, let's go quickly through it. I'm sorry for that. If we reach the CAM part, then they're going to get the BTLX file, so basically the milling information, and for each and every part, and are going to create the G code out of it. And they're going to add a simulation, a time simulation of it as well, and as well some statuses on it. How way over do you? Okay. Okay, the boss said it's okay. Thank you. Okay, I'm gonna quickly I skip a little bit of it. It will, so I said, the status and the production time will be wrote back, and then we have the machinery, which will feed back all the statuses of it as well. So in the end, what we did is today we have a structure with a lot of different interfaces, and tomorrow we could use that collaboration database is to improve the ways we handle data through the whole project phase. That's basically in the end as easy as it is. All our infos and data is on GitHub available, and we're already talking to how can we do the next step of it, or next step of that common database. So what I said in the beginning, we reduced it by 1.5 problems. The one is we created some kind of a collaboration database, and the other is we improved our English a little bit, so at least half of a problem. Thank you very much.
Thank you. Do we have any questions from the audience? So then we move.
What do you think? Who should take over the role to further develop this environment? Just industry partners, or?
Good question. We were already talking with Katarina how to do a small project out of it, because I think next important step would be to discuss more about that JSON structure, because we set the first example. It could be used, but it needs a certain structure, certain rules, and I think this is very important that someone take care of it, that this structure remains flexible but has its ground rules. And I think that needs more time, a little bit of sweat in it to be let's say, to not only be a database for these companies which are here, to be a more let's say open book collaboration database.
And I would say we go to the jury.
Small question. Did you also take part ownership, as data ownership and access control into your considerations?
Somehow.
Manifest itself in the project itself, though. Okay. Yeah, we talked about it at fair length, and didn't come to any conclusions about how to manage it.
Yeah. I can tell from experience, because we are working on the business integration platform, that data ownership and access control is one of the big hurdles in this kind of projects.
I think you definitely displayed your ability to integrate large teams from various perspectives. Congrats to that one. If you would choose one problem that you said there, you would have brought in the biggest contribution in the whole range of aspects you addressed, which one? Where lies the biggest contribution?
For myself, I would say the biggest contribution was to get everyone online with so much different perspective, from architectural design, timber planning.
Yeah. That's the overall view. Like in the range of problems you solved, you have 10 problems solved. Which is the number one with the highest contribution?
Getting data in the same structure. Use it by different perspectives.
That's all still overall. I am repeating it last time. Which one is the one with the biggest contribution? Where's the biggest impact in the whole value chain?
I think it could be the production time, the real production time at the end, and it should go back to the database.
So like in the handover to the production and then the production efficiency in the end. Okay, cool, great, thanks.
All right, then I would say we slowly move on, or yeah, all right, let's move on. And picture, yes. Next one is IFC data bus.
You're done. Leave your screen up for the picture. Don't unplug it.
Hello everyone, I'm Daniel with our team from IFC Databus. We are going to present you our solution about how to exchange data in a smooth way. The current problem is we have data, we have a project, and we have an architect who is providing data, and within a project we have a lot of contributors who are working within the data, within the project, and within the project the data needs to be exchanged between the different stakeholders. So what does it mean exchanging data? We don't want to exchange whole IFC files within a whole bunch because it's getting larger and larger, and we want to exchange just data on element and element properties level to contribute with the team. So, for example, we have an architect who is providing the data, and we have a facade consulting, building physics, safety planner, and they are enrich models, data. Some of them they need it in their own way, and some of them needs to be going back to the architect or to other disciplines. So you see, the problem today is we have a CAD system, for example. They are providing the data to an analysis tool. They are doing their job, and they're producing some valued data. Some of them are remain, some of them needs to go back. Going back is currently stopped without any coming back with the data. So also, what is possible today is, for example, the speckle, we have heard from them, but this is not following OpenBeam standard, for example. We want to go with the OpenBeam standard, which is much more wider. To produce some of the how we did it, we explained.
So the idea, instead of using Speckle or a similar solution, Speckle is a centralized solution. So the idea was to decentralize the distribution of the data. And for that, we fragmented the IFC into entities. And the thing that is being sent over this data bus, it's never a full IFC, it's only the entities of the IFC document. And the technologies that we're using is a queuing technology, specifically MQTT, which is a very lightweight protocol. We started writing a client in Python using Compass Eve, and a data structure called automerge. Automerge is the thing that actually provides a lot of the heavy lifting because it's conflict-free replicated data types, which means these things are offline first. We can work on data on the entity, make changes to it without being connected, get a history of the changes, and then when the client reconnects back to the internet, it sends everything into the bus, and the other clients can take that data, and automatically merge it. So we started with the idea of having 2 clients, and we ended up having 6, 7, whatever. And we will show them in a video a bit later. So we have an ArchiCAD one, a Grasshopper one, Blender integration, a web client, and legal code.
So okay, let me start the video. Okay, so yeah, now I'll show you a brief video of how does it work. So basically, the architect is working on his model, but there are other stakeholders in the project, the facade consultant, the 3D artist, and everybody is using their own softwares and technologies and whatever. But what is important is that they are all connected to the IFC data bus, which provides a common ground to make these software talk. So for example, let's say that the architect has created a wall. He can use the ArchiCAD plugin to publish the information regarding only that wall to the IFC database, which will transform, which will be sent as a JSON and read by the clients on the other software. So for example, the Grasshopper interface can now make changes to that specific wall geometry, either with the interface, or since it's a JSON, actually, it's a text file, so you can change it in many ways. On Libel, for example, at the same specific time, you can make a change to another parameter of the same wall. For example, in this case, we are changing the EPKBA. We also have the possibility, okay, so yeah, exactly. Now you see that the value has been changed into the JSON. So in this moment, the Grasshopper and this interface they do not share the same information, but once the informations are published, the IFC database takes care of the different bits of information that are sent, and through the ArchiCAD plugin, we can retrieve back the information of the AEC database. And at this moment, we crashed. But that's it. This is just a quick video of our GitHub project, how it evolved during the weekend. Okay, so thank you. Let's conclude the presentation.
Sorry. So yeah, we started out with 2 applications. That was the goal on Friday, to say we want to connect 2 applications, but it ended up to be 6 to 7 integrations that we actually managed to connect. Thanks to the fact that we acquired quite some talents on Friday, people who joined our challenge. So in total, we were seven domain experts, architects, civil engineers, but of course also software developers. And over the course of the past 2 days, we wrote over 2,800 lines of code to make this possible. Our conclusions: we believe that this novel approach, meaning the possibility to work decentralized with different analysis tools together, is a complete different, a new way, a new paradigm on how to look at collaboration. We believe that there's a huge potential to really solve core problems of this industry. Of course, this was just the first POC to prove that the basic idea could work and make sense. And our next steps is that we will refine the protocol. That means the language, how we exchange this information across the bus, make it more robust, more performant, and allow better controls. Plus, also to decide on the concrete conflict resolution strategies, how to deal with different versions of the files, and how to make sure that the data remains reliable. So IFC 5 is also on the way, so we will tackle as well, or review as well, in what regard we can align with their goals. In the upcoming weeks, we will have another session, another meeting, where we come together and discuss how we can advance the protocol from the current state. As I said, it's just an early draft, and we want to make it more better and get to a production-ready state. So if you want to join us, please contact us in person after today, or just on Discord. We have a channel there. So thank you very much.
All right. Questions from the audience?
It sounds like a bit like USD, Universal Scene Description. Did you discuss why you didn't use that? Why you did go for a different approach?
We believe that on the foundation, we should look at what is available as a common file format to exchange information, and IFC as a format is a very strong case. You can say it's slow, it has its problems, of course, but it's a common denominator we have in the industry. And what we intended to do is to really use that, what is available there, and just have a protocol as a way to exchange information. So that was our intention to really, go a different direction, and we haven't investigated, let's say, a variety of other tools. Yeah.
Okay, one question from us. You choose auto-merge instead of working with Git. And I was curious, what were your reasons?
Auto-merge is just the data structure, so it's network agnostic. We work on the individual entity using auto-merge on an embedded basis. We don't rely on any external service or servers. And then once we have the data, that data we can send around. We're not using auto-merge transport layers. We're just using the data structure and the encoding that it has. And then we use the MQTT transfer protocol because it's easier to integrate in many other platforms.
Like all those version control systems, there's one point in time where you definitely run into a conflict situation.
Yeah.
And I'm curious, did you try to reach a point where you had this conflict situation, where you had to manual interact with conflicts?
Then we have an example that has two replicas that run, and they make changes to the same document. Of course, it's a very contrived example, and they do update each other. And we have the example just uses last right win strategy, but it's you could configure auto-merge to have more advanced resolution strategies.
Okay. Thank you very much.
Thanks. Okay. Sorry. No, we're not done. We're not. So looking back maybe 2 or 3 years, so message queuing was really hype, and I'm personally super happy to see that it's becoming more a talking point in our AC world, as I truly believe it's the only way forward to move more into hyperscaler environments and be able to connect into this environment. So, but challenge is less the numerical data than the actual geometrical data. How far did you expand your testing into the geometrical questions?
So we scoped the challenge particularly for non-geometric data. This means semantic data. We took a wall with information about different specialist attributes that were exchanged. But at the same time, we also tried out geometry, so that also was part of the thing we tried out. It's not part of the challenge, but we tried it out. And there, obviously, the format we have used was IFC JSON, which has a lot of overhead, obviously. But there's a room to improve this. I mean, you can encode this information with protobuf, with flat buffers, different ways how you can encode this information. So I think there's a lot of potential to make this very fast. But the main use case is really to deliver information in an interoperable way and make it easy for as many software vendors and as many tools as possible to just plug in without a lot of effort. And therefore, you have to make a trade-off between performance and the ability of ease of use, basically.
Okay, so the question is, the answer is basically yes, you believe it's doable.
Yes, we believe, yeah.
Okay, so we see you next year again then.
Yes,
with that
absolutely.
Challenge. Okay, looking forward. Thanks so much.
Stage big enough for you?
Zu den Timer wieder dran.
All right, next up is windows of opportunities.
Oh no.
Dass du kannst ab und zu da drauf.
Und das andere? Yeah. One sec. Maybe I start by saying I have no IT skills and I joined the challenge with an idea and I found a team who made so much possible in one weekend. I was thinking it would take years to achieve what we did like in 1.5 days. Yeah, so that's the team. Most of you probably know 84% of the waste in Switzerland comes from the building industry. And while there are a lot of different firms aiming to reduce that waste, Windows still stay very difficult because nobody really knows how to use Windows. And that's what we tried to solve this weekend. So basically, we try to connect different stakeholders from the construction industry, the one who have Windows to dismantle or to throw away, and other stakeholders who want to buy reused Windows. This all happens within an interface online. And with this, we're able to save up to 90% of the CO2 compared to the production of a new window. This all happens into a database. This database is then linked with the scoring system, which allows the different stakeholders to see what reuse potential they window have. We have a lot of information in it. Several of them are very important. They are mandatory for us. This then allows us to define the scoring system based on today's Swiss norms. We have more criteria than those listed here, but it's only if they were available. The system then allows a lot of people with no window knowledge to know what's possible or not, and so we use more windows in Switzerland. So we have this live demo.
Yeah, so you reach the landing page and you can basically log in right now. And then you have the two options of either finding a window or adding a window. We already have some windows in the database where you can see their location and all their criteria, the parameters. And we can also add a window. So you have to add all this information. Some is obligatory and some is not. So we already added some to not constrain the time so much. So we can submit this. Here. We should be able to. Do I refresh the page? Okay, yes, upload successful. So now we should be able to see it on the map down here in Vitikon, where we added just now some of the windows. Exactly. And then go back, no? Yeah.
So this is kind of the first steps. We now want to implement a more detailed search engine to really match the different stakeholders, not only based on the Windows properties, but also based on where they are and when they are getting dismantled, to make all the logistic behind the construction also way easier than right now. We also have a lot of ideas of what we want to do in the future. We want to implement the CO2 savings, maybe even generate CO2 certificates. We want to put 3D models for architects to put it in the project right away. We also want to do the inputs data way easier for big companies. The easiest way is some CVS template that we can download, fill in and reload. But we were also thinking about OCR bill reading, so that all the data would automatically go into the database. And we also don't want to be one more database within 1,000 other ones. We will want to integrate already existing marketplace and take all the information we have and put it available there for everybody. Yeah, thank you. And you can access to a lot of information with the QR code.
Questions? Anyone? There's one. There's. Hello, just a question. Who can upload the data? And the second question is how are you checking the quality of your data? So if I'm uploading just a broken window.
So basically, anybody interested in uploading it. The big potential is with window manufacturers because the quality is good. They have all the information, and so it will be possible. They have the data of the 15 last years digitalized, so it will be possible to see what kind of window will be available in 10, 15 years, maybe even sooner. There's also big real estate companies who could, for example, just put all the information in it, make it private, and then reuse their own window within their own different buildings or projects. And yeah, for the quality, it's mostly, it depends a bit. We will need to control it. It's also a big question how the stakeholders will discuss between themselves, if it's just a phone number or if it's really well, or more organized.
Can I ask what's actually the tech contribution? I mean, that this makes total sense and it's a great, great candidate for a hack for humanities, obviously. But what really, looking at the available circularity indexes that are coming along, or is, where is your technical contribution into this?
Answer this, but I think what I'm mostly happy about is this scoring system. That really every window that is put in it is automatically analyzed, and then it gets its score. Yeah, maybe on the table. This one, and then with this score, you can see what is the potential of the window and what would be the best strategy.
I keep on challenging you. That's the nature of a circularity index, that it gives a score to something. One deeper, what's the technical contribution?
So Michel provided us, so there are years of work of research behind that, and we were given this information in terms of, so it's research and algorithms that are passing behind. So in the back end, we did the work, what you probably don't see this here. And while she's involved into the research of providing us this accurate information. We're just taking this technical information and create an algorithm. So this could be in the back end, given her research and time, that we can enable that and optimize these parameters, or even the way people can connect. So I don't know if this answers your question entirely in terms of technical, but
I think it gives a direction, like an advanced index,
right?
Yeah. Coming from more whatever relevant information on how to index the.
Exactly. So maybe Michelle was a bit humble and explaining and modest, but she presented us with a lot of research, and actually you can visit. Maybe you can show all the participants the window and the years that she's doing and explaining that to us as well, so that we can interpret and transfer that data technically behind where you cannot see. You just see some indexes right now, but this further can be improved by her own research and discoveries.
Okay, looking forward to that. Yeah, thank you.
Sorry, I have a very technical question. I saw in your code that the basic algorithm was implemented in MATLAB. Is this correct?
So I'm responsible for that. I'm a structural engineering background, so yeah. I was working in MATLAB, but then we transferred that to Node TypeScript for our team members here who are software developers, so they can answer more deep questions to that. So it's not entirely MATLAB, but we started from there because I have that background, so I could help with it with my knowledge.
Okay, but this was a manual process to transfer this. You just wrote in the README that it was interpreted into Node TypeScript. So this was manual labor?
No.
You just converted it technically from MATLAB to Node TypeScript. Okay.
Yeah, obviously, no, not manual. Yeah.
Okay, thank you very much. Second question, you say that we can use it right now, but do you have any login?
For now.
Okay.
It's a test, but yeah, you can use it, and
yeah. So the authorization system is next step also.
Next step. Okay. Thank you very much.
Yes. All right. Thank you.
Projektname oder so. Euer Projekt. Jetzt, ja, dann die Bühne verlassen. Right. Bridget is next up, right? Yes. Yeah, just wait a second.
All right. We're here to present our challenge. It's called Bridget, which we identified and developed entirely over this weekend, which is about matching design comments on detailed PDF drawings back into your geometry CAD software, specifically for bridges. Context is something that's extremely important for designing bridge structures, whether it's spanning across railways, water bodies, or in a scenic valley. And this is what often decides, is it an arch, a cable structure, or a trough? And since it has to be very sensitive to its context, this is the very reason that it goes beyond structural engineering. And there are many different disciplines involved: civil engineers, architects, traffic planners, and so on. And of course, everybody has their own tools, state-of-art methods. And thanks to many people like you, a lot of open source tools or licensed software is available to exchange data or industry standards to be easily met, such as JSON, JSON, IFCs. We've even seen blockchain. I mean, we have it all, right? But in the end, PDF takes it home, especially with bridge structures, because you have to comply with very strict manuals and standards, which is just the accepted standard of construction. So very often during the design development stage, you find yourself in this stage where engineers or architects are going back here, and this is basically the design board after a certain point. And the modeler or the designer is left to make sense of this, and particularly in large infrastructure projects, this could be a major headache, and then they go through their digital pipelines, whatever, however advanced that is.
Thank you very much. And this is the state of the art where we are right now. We have our 3D model, and we export out of it a 2D PDF where we send to our other planners, where they put a lot of information in it that is very important and crucial for the project. And we can't put this information back into the 3D model. It is not a bidirectional connection. And what we end up with this is like we have more than one person or one people that we have to do it. It's more like one, two, or a lot of many. And we spend more time on looking at PDFs than the information that are on the 3D model right now. And this is exactly the way where we bring in Bridget, where we allows the bidirectional information from the PDF back to your 3D CAD system. And how we do that, we're going to show you right now.
So here's the situation. I'm a bridge engineer. I spent time, blood, sweat, and tears on my bridge design. Now it's finally ready. I made a drawing. I'm ready to export it. So I will launch my Bridget user interface, export my PDF, save it, and sending down the line to my colleagues for review. Somebody receives that, opens it. What a nice bridge, but there's a small issue there, so I'm going to write a comment. Please raise the heights of this element. Typos are important. Save it, send it back by email Monday morning. I received that. Nice, I've got comments. I use my wonderful user interface, import PDF. Choose it, run it, and here we are. The comments appears directly into the 3D model. We're able to match the position of this text dot with the geometry that we have in the model. So this comment is directly related to this beam. We store a bunch of metadata like author, dates of creation, and so on within the object in Rhino, and we are able, using a nice layer structure, to basically pick it up on the other side and later use it to display, post-process, whatever we want to do with it.
Thank you. So the way we do it is by embedding basically the coordinates of the view that the layout is representing. And this we can hide in the PDF. We can make this super small. We can even make it white so it doesn't even like show up invisible. Then someone puts all the comments onto the PDF, and this PDF gets then imported and is now on world XY plane. And through this Bridget code, we can remap it onto the location of the 3D space, and then we can match the comments with the 3D geometry. And if we find, if a match is found, we highlight the geometry. If not, if it's just a comment somewhere in space, we just represent it as a comment floating in space. And finally, we have this visualization where we have all the metadata. We have date, author, comment, and we could add many other things to that metadata. So as next steps, we would like to implement this on not only planar sections, but also curved sections, and obviously implement more types of annotations, such as images, sketches, even handwriting could be an option. And with that, I would like to thank you for your attention.
Do we have questions from the audience first? I don't see any. So maybe we'll use the jury. Any questions there?
Maybe a small one. I know that there are at least 3 different ways to add comments to a PDF. And which ways did you support?
Which way do you use?
I use all the versions.
So it happens to work for quite a lot of different comments because they are usually similar structures. We always have like an origin point, we have the text, we have the author date, and so on. So it works for this, I don't know, these speech bubbles, then comments with leaders, just free text objects, but also it could work for other types of annotations, such as line drawings or any other objects.
And when teams do get into an elaborate discussion, PDF commenting platforms that let you say, draw them as vectors, like PDF Exchange is preferred. So at some point we might have to draw the line and say that you use a good editor.
Thank you very much. I don't have a question, it's a comment. I was seeing this and thought, that's so simple. Why wasn't I coming up with this hack earlier? Great.
All right. I think one more.
One more question. What do you think about, let's say, long-term goal that in a golden future where we have like a working non-shitty IFC and a data-based workflow? Like, can you envision that this would get rid of your solution?
Should we get rid of, I mean, it's not about the PDF, it's also about the syntax, how you make the drawing, right? So if it's not on PDF, then maybe it's on your models, or it's on, at the end of the day, there is the syntax that you need to execute to build your bridge. And in that case, I mean, some teams had some of these ideas where maybe the comments can be searched in from the syntax manual. If somebody, I mean, we get drawings back saying the tags are wrong at a certain stage. So it could just be that you search and you can kind of automatically update some of that syntax. And it should be very feasible, like if given a development budget within like something you could do this year, for instance.
Yeah. I mean, this is an absolute brilliant life hack, what you did here. But to be honest, it's like duct taping a bad situation we have.
The day we don't need that,
yeah,
we'll be happy.
Yeah, exactly, exactly. So it's a stopgap solution before we have a real solution, right? And a real solution for me would be to have a data-based workflow where all the participants can add their comments and have like a live view.
Yeah, I mean,
we've been waiting for that for 10 years.
Yes, I know. Let's do it next year.
I mean, yes and no, this is not just about Rhino and PDFs. Like you can code this geometry, or you can do it in Blender, you can do it in whatever. It's like you said, it's about having that data structure. The 3D to 2D is generated automatically, and then you comment, and then if you change something in one main source, and then everything sort of updates. So within the speculated time, we wanted to be able to talk about all that by showing this very small link.
But just as an addition, it's a human-centered problem, right? It's a cultural transfer, and there are a lot of engineers working with 2D files and PDFs, and they will now and even us as architects, we're still working. We do like 2D and profiles because it's like simplifies a complex model into an abstract one. And I think it's a really important question, and I think that it's still gonna be something useful even in the future if it's like all the metadata is.
Maybe last one.
If I can add to this, or I mean, yes, we're here for the open source construction community, or I think this is like a brilliant example of really solving a problem, bringing it back to the industry, and really bringing a contribution where you first think, hey, that's so simple. I'm not sure what, but then you really get it, and it's really genius. So thanks again. This was a lot of fun. Thanks, really.
All right, please on the stage. Do you have like a background? All right, and also next is Voxel.
Now it's on. Okay, great. Thanks, everybody. My name is Craig. This is my lovely team of voxel enthusiasts of 9 who've come together to help solve a problem that geoscientists like me have communicating with other folks, folks like you in the construction, engineering, and architecture sector. We've titled this project Making Underground Voxel Data Available to the Masses. So a big challenge in communication I have with civil engineers I work with is communicating about what's underground. If you're going to build on the ground, through the ground, it's important to know what's there. And I'm heartened to see how much underground information is starting to appear in building models and in BIM. The status quo, as I see today, is you'll bring in solids representing different materials, assign properties to them, so that you can use them in the workflows that you're familiar with. That's a great start, but folks like me working with underground natural materials know there's a lot more complexity there. Using solids ignores uncertainty, ignores variability of materials, and I have a lot more rich information to give to folks who are trying to build and manage those materials. That's why we think voxels are really the future, and I'm excited to see there's starting to appear in more disciplines. And they allow us to do, they enable engineers and folks like me to do much more complicated analysis. The challenge is voxel data formats and files are not easy to bring into existing workflows and software. Where they are compatible, they're complicated to use, and they tend to be large files. So our goal for this weekend was try to make voxel data more accessible for AEC practitioners and decision makers. So there were a lot of different paths that our team could take, but these were the specs and the success criteria for us. First, with large files, we probably need some sort of tiling to be able to zoom in, zoom out, and interact with these data without being too laggy. Georeferencing is really important for context. What good is a floating block model in an empty void when you don't know where it is and where it is relative to your structure? seeing underground is a big key priority. A lot of web viewers assume that you're looking above ground. And of course, accessibility. We want something that's web-based if it's possible, or at least in familiar software. And ultimately, no matter what we go for, we want that scalar fields, or at least data that varies continuously underground, is available. So I'm going to talk about the 3 routes that we ultimately chose. Some of the alternatives are up there just for your reference, but this is where we ended up. First, about half of our team roughly was working on this Cesium web viewer. Why Cesium? Well, Cesium is a web platform for 3D visualization. It's a good choice because we have georeferencing and it's easy to get context data in there. Plus, they already have UI built in there. But key is also the fact that they support 3D tiling and shaders. We tried at first using a Voxel 3D tiler. Unfortunately, that's still very new within the last year and experimental, so we had to fall back to using point clouds. But still, we got this electrical resistivity model that I brought with me from Norway into this 3D viewer with all the data, not just the exterior shell, not just some solids, it's truly the scalar field. So that was a great start. Another one that we tried was Speckle. That's a familiar platform for folks. Here we extracted those cells from our structured grid, turn those into points in a JSON file, and try to bring it to Speckle. But in short, the data's there, it's still loading. So that might take a couple days. It was about 200,000 points in the small grid, 800,000 in the full size grid. So yeah, we tried, but still some work to go there. And lastly, NetCDF is a common grid format supported in the climate sciences, and we wanted to try to use that for underground. It is accepted by ArcGIS, but the main challenge that we had was climate scientists like long, engineers, geoscientists like me like projected coordinates. And that's why it took us some time, but we got that model in there in the end. So at least it's something familiar to a platform that's familiar potentially to many of you. So I'm already short of time, but if you want to check out what we did, our results are available online at this GitHub parcel. Thanks for your attention, and we welcome questions.
Audience questions? Doesn't look like it, so maybe let's move to the jury.
I start with an amateur question. That's really not my field of expertise. So you had all these candidates of all these solutions, and why did you move into the direction you are heading to?
Maybe Sven or Alex, are you guys adept to talking about Cesium and why we went there?
So the goal really was to, so underground data is very large scale, as we noticed, like it can easily reach 1 million points. And that means that these viewers, they need to have a sort of more dynamic way of visualizing the data. And these systems like Cesium or other similar web viewers, they have a standard called 3D tiling, which allows you to do specifically that, which is why we went for that route essentially. But we chose Cesium, but there's actually another one from NASA which uses the exact same open standard, and we like sort of juggle between the two as well. So yeah.
Okay, got it. No more questions from us. Oh, one more.
Could you please put up the QR code again?
Absolutely.
That was a question. So what's next? What are you going to do with that? Found a company?
I already am a co-founder, so I'm a little busy, but I think we are still intrigued by that voxel tiler from Cesium. I mean, getting the points in there was still cool and its performance, but actually having them fill the proper volume that they're supposed to represent, I think would be a really big step forward. So we're hoping maybe the documentation for that gets a little better so we can follow along what the Cesium folks are.
One other question. How is it with the georeferencing from like parameters or something? Is that already thought of or?
Well, I mean, that's one of the advantages of cesium is that the georeferencing is part of that. You just give it a ESPG code representing the coordinate reference system, and it takes care of that. Am I right in saying that? Yes.
Just another question. You found out that the strength of cesium is voxel data, or it's very strong in this field. When you want to mix and match different formats, so do you think it's still the best? Then, because I can imagine that architects won't work with voxels.
Possibly not, but I mean, I think the real key here is just to get the. Yes, it is on. The key is just to be able to get access about the insights. So if I can bring back one of these examples, just knowing where there's rock, where the interface is, isn't always good enough, because if that occurs right around the level of where you're planning to build a tunnel or excavate, 2 to 5 meters of uncertainty can be critical for the economics of your project. So with a probability model like this, if you're looking at nuanced information about where am I actually certain, where does this line in the solid actually represent reality, and where is it just the best guess, those are the kinds of insights. So I think the first step is just to at least give someone access to view that insight and help them make some critical decisions. Maybe long-term, getting it into design software would be of interest, but just getting that key communication tool up and running is, I think, the first step to any of this.
All right, I would say then we move to the last presentation, if I'm not mistaken. And please on the stage.
Hello. Hello everyone. So we are 2D to CO2 team, and this is our challenge. So, partner challenge. Okay. So it's called 2D to CO2, and the idea is that we started with the question: how can we evaluate the embodied carbon in the existing infrastructures? And this is what the existing infrastructure looks like on the documentation level. And what we can say that this is actually a huge pain. So we have like dozens of data sources spread across various silos in various formats. They have different owners, and all of this information is really, on one hand, not accessible, but on the other hand, it provides the really the gist, the essence of the building, and it contains all the description that we need to perform our evaluation. Here next. We have split the presentation a little bit so that each of us presents the.
So to start off, we kind of had to look out for a workflow. First, we thought of the big BIM button. So we press the button and we go from whatever data we have to whatever we want. This magic button doesn't exist. So we first had to kind of think about what we actually want to do. So we have the pane that we have as input, and then we have technically 3 workflows with each a different dimension. So the 1D analysis, meaning going from PDF documentation to structured data. 2D analysis, meaning we have our floor plans and we have room information in there, whatever not. And also this 3D analysis, going from the 2D plan to a 3D model that we can then inform with the information given and integrate that into a whole complete BIM model. So yeah, how do we process all that? Well, first of all, we use our PDFs and images and process them with mostly AI. To get an ontology model. And as we see on the bottom right, we have like room numbers, room types, which are already given by the floor plan with current, like with the information to them, like their IDs that we can map, and also with material information that we get directly out of those images that we can then map onto our 3D model.
Correct. So the ontology model gives us the system. So it gives us the understanding, the list of concepts which are connected with certain relationships, which gives us an understanding of what our infrastructure contains and how those parts are interconnected. But what are those parts? That was the first question, I guess. So, and how do we find those parts? So if we are architects or engineers, so when we look at this plan, we immediately see different walls, but what those walls are and where they are and which properties they have, when we look at this from the standpoint of a computer or of some digital system, this is completely unknown. This is just a bunch of pixels with all the knowledge completely hidden, but still implicit in it. And we started with two approaches. So first, we need to, wait a second. So first, like the colors that you see. So we need to standardize this a little bit. So, and we have to rely on some widely accepted standards. So this is SIA. And we had to take the most important categories for CO2 calculation and to extract them from this plan. And for this purpose, we have created two machine learning, adapted, better to say, two machine learning models. We had to label data a little bit, and the first model actually works, as you can see. So there are actually four categories, which you can see now. So we can see facade, which is not always like separate from purple, structural walls. We see columns, and yes. So this model would allow us to understand. So this point and plan, which Baukostenplan category does it belong to? Yeah, I cannot translate this. So to which Baukostenplan category does it belong? So we know that the purple curves are internal partitions. The green ones are structure. So they are C0, 2, 0, 1, I guess. So we know this information, but what's next? So we know those pixels, but how do we get to the actual building components? And yes, the actual building components. And for this, we need another model. And this model should take the plan and it should tell us, so exactly at this position, what kind of building components with what kind of extents do we have? And later we can combine these two sources, combine the classification, semantic result of the semantic segmentation and result of object detection, and we can actually get the 3D. So here you can see the labeling step. So this model, I think we kind of trained it, but already in the meantime, during the presentations, so we don't have the ultimate result. Yes. So, and from this we can get a cohesive and complete understanding of at least at this point, at this step in this process of two-dimensional structure of the building, segmented according to categories and yes, with geometrical properties. Oh wow. Okay, we'll be fast. This me. Okay, so but the ultimate step from this is to extract the three-dimensional model, which would allow us, because yes, we know two-dimensional structure, but from documentation, we can also extract from all the drawings, elevations, and facades. We can also make assumptions about what the three-dimensional structure of the building is. We can extract floor heights. We can extract even like non-uniform height kind of levels and so on and so forth. And we can assume what is the three-dimensional structure of the building. And so we can get not only the planar information about the building components from those drawings and from the documentation, but we can also extract three-dimensional picture, which could help us to do like predictive maintenance, to schedule refurbishment, and actually it could allow to do much more than just monitoring the embodied carbon level. That's fun. Okay, so when we have our components, so we know where they are, we know which categories they have according to SIA, we know their volume. Well, let's assume. So what do we do next? So we still need one more crucial crucial element in this calculation, which is building materials. Building materials come from the same source. So we have this huge pile of unstructured data, which we have to somehow like process. For this, well, we obviously use ChatGPT, and for this we actually use the database of 2050 materials, which Juanes generously provided us, and we managed to, from the drawings, as you see here, from details, and we actually don't know if those are details, plans, or sections. We just like throw in a bunch of PDFs. We can get a report on the assembly level. So assembly is like a facade system or structural system or facade structure ceiling, for example. So we get a report and we can match it with the database and we can get the CO2 potentials per assembly. Double the time. Who's this? Okay.
Give me 20 seconds. So with data integration, we have all our 3D data or semantic data. We match them together in Speckle, and we analyze them either with GraphQL and then in Power BI to give the user some feel of what they've done and what they got of their building. That's going to be then shown in a web UI with where you upload the stuff, and in the end you have your full analysis out of that. And can we implement that on Monday? Probably not on Monday, maybe on Tuesday. So thank you very much, and have fun.
Any questions from the audience first? Yeah.
It's actually about the scope. Why would you want to assess the embodied CO2 of an existing building?
That's well, ETH has sustainability goals, and one of those sustainability goals is reduction of carbon footprint. And carbon footprint consists of several scopes. We know scope 1, scope 2, scope 3. And if we can evaluate all the direct emissions and we can evaluate some of indirect emissions to actually track our curve, like our downward sloping curve towards like eventual net zero, we have to know where we are standing. And where we are standing is largely dependent on the carbon and carbon amortization in our infrastructure. And currently, we don't really know how much carbon there is. Yes.
So you want to like calculate the carbon that is embodied like as a budget?
Yes. Yes, and it can also inform, for example, because currently projects are evaluated, like infrastructural projects are evaluated on monetary basis. So we have some budget, we have some timeline, so we have some like projections, but there is also another dimension to this, which is carbon, and which is really not, we can translate between them, but it's not always direct and not always correct. So we want to know it exactly.
Okay, maybe I have to ask you again, but I want. Okay, one.
Maybe one question from the jury, if they have one.
Just to the technical background, how would you orchestrate this management of the data from A to B to C? What do you have a vision on that?
Technical. How technical?
It's like you put it in a hyperscaler cloud environment and you process it with message queuing, or was just any idea behind that?
Something like that. Yeah, so it's like, I think it's like, yeah, normal cloud environment somewhere on Azure. So we just deploy a model. Yeah, we build a web app. So some event bus where we send some processing events.
Yeah, I think we move on. But first, the stage is yours. All right, last but not least. OpenPlans X. Takes usually a while. Put a little timer so you have like more or less as much you can get.
Hey, all right. Our team name, it's called OpenPlans X. The X in the end is because, let's say if Implenia and 2050 materials had a baby, so then that's something, the challenge that we worked for this weekend. So what exactly OpenPlans X aims on solving? It's I won't bore you with all the things that we'll be fixing, but it's about making the design decisions really early. And then you saw a few slides that the application was crashing at the end, the application was not responding, and the problems like that. So what if there was a tool which helped you make the decisions as you are designing, as you are developing, and you get the collaborations really early on. So the flow exactly that we followed was Implenia had a nice JSON data set of the floor plans that they have scanned. So we took in the JSON data sets, we ran it through OpenPlans converter. We used OpenPlans as a tool to show the floor plans. Then there's something Open Geometry kernel, which is an open source project that I have been working upon. And then we visualize it. We use 2050 materials, and then I'll show you the demo just to be clear. You guys can scan the QR code if you want to see it live as of now. So let's say now you have this floor plan generated from Implenia JSON dataset. You select the material, you get the carbon footprint. But then just selecting tiles are not enough, right? So let's say you add in a window over here. You get the carbon footprint for this as well. But then the window doesn't match the scale. So let's scale it down to make it look good. Let's open up the windows as well. And now we add another window over here. We do some changes for this as well. Then let's add a door for the bedroom. Just adding a door doesn't help. So we need to change the quadrant. So the quadrant changes the angles for the door. Then we rotate it so that it matches the wall alignment. And this tool is something, it's an open source tool that I have been developing. It runs on a geometrical kernel. Yeah, then you fit to zoom. You do some more changes. You add a door, you do these changes, and it's done. So this is what OpenPlans was about then, but how do you use 2050 materials? I guess Chandra can tell you.
Yeah, so we are delivering a carbon data, more of a sustainability data also together with that LCA with an API. We have more than 150K products, 50,000 products, and more than 12,000 materials, which can be extracted from an API, and there are various number of parameters. This data is aggregated so that the architects can use it and to make an informed decision at the early phase of the design. And this can be plugged into any tools which architects are using nowadays. I think that's all I wanted to say about 2050 materials. That's everything is available. And there is also UI, which almost every product actually gives almost equivalent of a digital passport, digital product passport, so with various parameters which are there with the LCA lifecycle data.
Yeah. So then what's OpenPlans? What is the geometry kernel that I was talking about? So we are coming up with something called anti-ecosystem, because you might have seen this diagram a lot. It says that we are building an ecosystem. You plug in our data, you do this, you do all this thing, but then it's all feeding price to a greedy system, and the nobody grows apart from the ecosystem who is run by these softwares. So what we are thinking to develop is more of these kind of an structure where the tools coexist, the APIs like 2050 materials coexist. So if you want to do carbon analysis, if you want to do site feasibility, it's really early in the design process. So we are kind of trying to develop glue of tools. Then the amount of code written. So the entire thing that you saw is the amount of code we have written, but the reusable code is something which we can share right at this moment. But the code that I have written for this weekend particularly is just this small amount of code. So you can just try to estimate the amount of things that you can do if you try to really, you can try to really break in from the ecosystem, because the entire thing that you saw, it's just 700 lines of a code written by Copilot. So you don't even have to write your own code if you want to do something of that sort. So this is the geometrical kernel that we have been developing. So if you want to go through the GitHub link, you can check that. What's next? So that is something which might make a few architects angry, but we are okay with that. What we are planning on doing for the next few hackathons is get auto-generated floor plans, so that even though you have this floor data sets, you can generate the floor plans really easily and have more tools plugged into OpenPlans, OpenGeometry, so that you can create your own applications rather than creating your own plugins and then relying upon these ecosystems, which doesn't help you grow exponentially. Yeah. So this is our team. Yeah. You guys, if you have any question.
Thank you, guys.
Yeah.
Perfect. Any questions from the audience? I'm not seeing anything. Anything from the jury? Any questions?
It's a bit of topic. How you are addressing with 2050 the European product data templates and so forth that are coming, and how do you see this in the open source context, and how could this be integrated in here? Like I believe that standardization plays a big role in the sustainability things. How can you make a link here?
Yeah, so we are already started working with the various standardization organizations, including SENS and ELEC. We are involved in some of the initiatives which are there. But as we all know that European Commission actually also funds the same standardizations of same type at multiple places, a bit of a spray and pray approach. So this is what my experience from last 15 years is. There is also HC, which is creating some standards, SENS and ELEC, ISOs are creating some standardizations on it. But eventually, the way we see is that it will all depend on the users who wants to adapt the various ontologies and how when we are talking about digital product passports or the product templates, what we are talking about, it all depends on how actually even the suppliers are ready to provide the data, because digital product passports, especially in the construction sector, it's useless unless we have a supply chain information and also real-time information. There are many problems needs to be solved before that, whether how reliable is this information, because we like it or not, 60% of the data is a manual entry. So that is something that which we need to solve. There are many steps to go forward, but I'm expecting that there is a battery digital product passport which is already in place with some kind of a standardization, and construction is starting slowly now with the Construction Commons and Eco Platform, these non-profit organizations in Brussels. Yeah.
So I think like the point that you have with this anti-ecosystem or in your presentation, or that might be very interesting to develop further and see how the mechanism of feeding in the data into the system can be, I'd say, sped up and increased. Okay, yeah. Thanks so much. One more question, sorry. Sir.
Yep. One more question. The source code you wrote this weekend, is this visible somewhere? Because I saw the commits on this page there. The last commit was in January.
Yes, so we have been not released because we have been developing all the code on the like not on the public, because as I said, it's co-pilot written code and it's really messy. But yeah, we can share you if you just want, just come over here. I can show all the code that we have written, and it's pretty badly structured as of now, if I have to say it, but it works. So the entire challenge of for us this weekend was to make it work, and that is something which I wanted to do. So yeah.
Okay, you can share it if you're proud of it then.
Yeah. Okay.
Yeah, and please remove my API token from there. Yeah.
Thank you.
All right, thank you guys.
Can you like please put it open for the picture?
So also the announcements of the winners will be around 5 o'clock. And also, if you haven't done it yet, there is also like this survey that's also still around. So maybe give that a try.
Hello, hello, hello. Kommt doch schon mal. Die Jury hier. Kommt doch her. Moni. Allah, Ursula. So we are ready to announce the winners. Ich würde gerne noch viel mehr sagen, aber ich kann kaum reden. Hello, hello, hello. Please take a seat. We would like to announce the winners. Everyone.
No Weinglas.
I think now everyone got it. All right. Sorry for that break that it was not so easy because I guess everyone is a winner that participated here. But we have 5 categories. And I truly mean this. I can't speak really, but this is really something that I believe that everyone who is here and contributed to this event deserves a lot. I think it's great that you all came here, and I hope what I mentioned in the beginning, that I hope that we see many smiling faces, that this became true and it feels like. So thank you again very much for all your energy and contributions. Yeah, so I can't really speak now. So we move on and start with the presentations. Ursula, you are the first announcer, right? You are. So we have 5 categories, and our jury will announce the winners and give a short introduction why the team won.
Perfect. So first as well, a big thank you from all of us, from the jury. And we could have discussed for hours more, and it was great to see that we have such a diverse approach to everything. So we as well try to be humble and really address various perspectives. But really thanks to all the contributions. And for us, they're all winners. But as we were asked to select some special mentionings, we of course rightly do so. And we would like to start with the best mashup project, or where we believe it's not always about having the newest idea or the most groundbreaking idea, but it's all about getting things together to get them work. And I think in our AEC industry, this is really a big ask, or to get the connection, the automation, or the digital continuity between the participants going. And in this case, we selected, and a big hands to the IFC data bus. Can you just come up for a second, please? We need you here in front.
No one's giving up.
Yeah, it was a long 2.5 days and nights. Please. One winner picture here. So to the ladies in the center, always, exactly. So big hands to the data bus team, yeah. Thank you. Handing over to Ursula for the second category. Thank you.
Thank you very much. So for me, with a background in engineering half and half architecture, I found it today very inspiring that people worked on the idea of making data more comparable and not rely purely on a CAD software when it comes to reliability, getting some numbers out of a CAD model. And therefore, we give the prize for the best humanity hack to the Data Blocks project.
Lucky me. I can again talk about my background. I was working in the timber manufacturing industry for the last 7.5 years. And one of, from our point of view, the biggest problem, but now not getting the prize for the biggest problem, but getting the prize for the best startup potential, is the project of Project Talking. Also, warum? Mach ich gerne mit dir. Möchtest du?
Just to add a little explanation why we selected Project Talking, we believe sometimes it's not about the deepest tech or to get things together, but you need to understand your business model and you need to understand how these business model actually integrate themselves. And you probably feel it now why you ended up in the best startup potential. And we really hope that you will delve more into this and get it going and get it flying and find the right technologies to do so. So big congrats again to the best startup potential, big projects talking.
Ja, was du machst, ist jetzt gleich mit dem nächsten, mit den folgenden Projekt. Bridget, weil ich glaube, das brauchst du ein bisschen erklären.
Okay, now comes the project which we had certainly the biggest discussion. How big is the problem to be solved? Is it really big? Where are we in this here? And after a lengthy discussion, the jury came to the point that we had a clear nomination, which we all agreed on, which we found will be Bridget. To give a little explanation, or first we were not sure whether this is really a problem that is solved or what's actually the problem. But once we got really into it, we understood that's something we have every day, or getting the teams together, working together, and that's so simple. And we will definitely look forward from tomorrow morning to have this globally available all over the world. Yeah, so looking forward. Thank you so much. So on to Ronnie for the final one.
Yeah, thank you very much. So you know what they say. What are hackathons? Hackathons are events where you convert caffeine and alcohol and pizza into working code, right? But actually it's about connecting people, connections. This is what hackathons are about. So and my absolute honor is to give the Best Overall Project Award to a project that deals with connections. So actually it's 2 projects. So we have a project which is already connected. So it's find the connection, and connection found. The stage is yours. Take it away. To give you a little context, what we liked about your project is that you had a brilliant technical solution, that you overachieved, that you absolutely had a 150% solution, not only an 80% solution. So thank you very much.
And to add a little explanation why we throw you in together, or I mean, you heard it with our comments earlier. We truly believe that you both touched it so nicely from 2 sides, and we believe in the synergy of throwing you together, and we look forward to see the results of that combination, of that connection. Yeah. So thanks again. So, and that's not scheduled yet. Maybe just as a little outsider, I would like to welcome maybe all the organizers for a second, or that we had here, or Max and whoever else is here, Konrad, Christian from the far, or we think of him, or just Alex. Where's Alex? Still already asleep. Who else do we have? Manuel, we need. Yeah, get everyone involved, and maybe just on stage. Okay, Felix. Okay. So I think we cannot thank you all enough for that experience, and that you really throw, I know, an endless hours into this, and and all your energy until the last medical whatever supports need to bring you back on stage here. So a big hand from all of us from the community. So much. So back to the protocol.
Yeah, we are almost there, I would say. One last thing that we would like to do is to take a big group photo as we did last year. We will do it in the main hall. Joey will go up the stairs and we will assemble on the bottom. And then we can all have a last coffee, a last beer, or anything else to drink before we say goodbye. And hopefully see you again next year here or at some other opportunities throughout the year. So thanks again, everyone, for coming by. Enjoyed it very much. Thanks.